Welcome back to Learning Unity with the 3D Game Kit. In this video, we're going to explore light maps, what they are, how they work, and how to set them up for your game. Light maps store pre-rendered lighting information, allowing us to achieve high-quality realistic lighting without the performance hit of real-time lighting. We'll also cover how to create optimized secondary UVs for light maps to get the best results, so let's go ahead and jump in. Coming back to where we left off in the last video, we set up our asset inside of here and we took a look at some of the maps. And one of the things that I kind of pointed out was this area here, the global illumination being set to baked. So what I want to talk about is light maps and how that kind of comes into play and how we can set them up in Unity. So what is a light map? A light map is a texture that stores baked lighting information, allowing for high quality lighting effects like bounce lighting, soft shadows, and color bleeding to occur in real time without a performance hit. It does that by pre-rendering this data, and that reduces the performance load compared to real-time lighting. So how do they work exactly? Light maps are multiplied over the diffuse texture, which is also known as the color, correct, right? Darkening the surface where the shadows occur. By using an over-multiply technique, you can even create overexposed looks if you want, where brighter light map values amplify the diffuse texture for a more vibrant appearance. Now, when we generate light maps, we actually need light map UVs in a UV channel. What's neat is inside of here, this will automatically occur in Unity, but sometimes we need to set up our own light maps, which we'll take a look at momentarily. But before we do that, let's go ahead and set up a scenario here and take a look at the light map baking techniques in Unity so you can see how the tools work and you can understand them a bit better. I'm going to start by just setting up a basic scene here where we have a plane on the ground, or floating in the center. Let me go and zero this out so it's on the ground. And this plane is large and bright, but I think the truth is actually our laser gate's really small. So I'm going to bring our laser gate up, make it a bit larger here. And if we wanted to, we could add some materials in here. I'm going to create a new section here, which is just going to be lecture demos. You guys don't have to do this unless you want to. You could make it a tutorial file. And inside of here, I'm just going to right click and create a material by going to create and coming in here and looking for material. And we'll just make this our ground shader. And we'll just drop that on the ground here by dragging and dropping. And then I can make this not white. That way it's not so bright. And I could go ahead and add in some more objects here. For the sake of simplicity, let's go ahead and just create some basic objects in here, like a cube, and maybe build out a scenario that we might see in our game. So for example, we'd expect some sort of wall to be utilized here to block in this gate, so that way we aren't going to be able to pass it. So something like this. And I might do the same thing over here. And then, of course, we might build some sidewalls as well. So that way we have a scenario that makes sense. So I'll just do something like this. That way we have these walls going. And then I can create a couple more materials just to kind of give these context, some sort of color. So we'll just make this color 1. And I'll go ahead and drag and drop these onto the side ones here. And I'm going to make these a relatively saturated red. I'm doing this for the sake of showing light baking, so you can see the effect it has. And then for these ones here, let me just lower them all so they're actually interacting with the ground. We could make these ones kind of a similar green maybe to the one we have, or maybe just leave them white even, so that way we can see some interactions with these. But I will make them slightly less white, that way they don't get blown out. And we can place those here. Okay, so let's talk a bit about the lighting setup here, what we have and how we can adjust it. We have a basic lighting setup in Unity where we have a directional light controlling a sky dome. So for an interior level, a lot of the times we still can use a sky dome if we want. We could make it darker if we wanted to kind of imply a dark area. We could also turn these off and get rid of these, and that's kind of the use of an empty scene. Now, we created this in here intentionally, but let's go ahead and just set this up so we have it maybe lower in the sky, like a sunset type setting, maybe even coming through the gate because that looks kind of cool if we put this in the context of like our character being able to run around. And let's add a couple other lights to the scene to kind of give a further definition here of the scene and what's going on. So I'll come in here to our game objects. We'll go ahead and create a light. And in this case, I'll create a simple point light. And we can go ahead and throw this into the corner here. We can adjust it accordingly. So in this case, maybe I make the color a slight yellow. And you can come in and adjust things like the intensity if you want it to be brighter. We can adjust the range if we want it to just kind of be like a small corner light, something like that. Now, so we can understand baking, let's go ahead and duplicate this and bring one over here. And we can adjust some of the settings in this lighting now. So when we deal with lighting in games, we have a couple different types of lights that we can change through, which you're familiar from other 3D softwares. You can flip through them here in the type if you would like to see the different types Unity has. But the more important thing we have here is this option here called real time, and that's going to be dealing with the mode. This is going to be how the game is processed when the game is played. And real-time lights are always active and they're interactive. I mean, they interact with other objects, they cast shadows, all that really awesome stuff that we expect lights to do. Of course, we do need to set them to cast shadows. You'll see by default they don't have that turned on. So if you wanted these to cast shadows, we could come down here and click hard shadows or soft shadows. And I could do the same with the other one. For the sake of things, we'll go ahead and do soft or hard on both of these. I'll do soft on this one. And we can create a sub-object here just to kind of give us another object to look at. We'll go ahead and maybe use something like a cylinder to represent a crate or something of that sort. And then we can have the effect here of this light casting a shadow. So maybe some sort of object in this scenario being lit by this. Maybe make it a bit smaller. That way we actually see it occurring in the light. And we can do the same thing here on the other side. All right, so let's talk about the different types of lighting here in terms of modes. You'll see you have real-time, you have mixed, and you have baked. If I switch this from real-time mixed, you'll see we still get the real shadows, but when we're baking, we can actually add in more baked information. And then lastly, we have baked, and when we have bake set, we shouldn't be seeing any shadows. In this case, we are, which might be coming from this here. But surprisingly, we actually still are seeing the shadows there, which is neat. Normally, those only show up when baked, but maybe it's giving us a preview. Not sure on that one. But we can set this to different modes for different results is what I'm getting at here. So this is actually giving me a surprisingly unpredictable result. I was expecting this to not show up at all, but I guess we get a bit of a preview here. All right, so now that we have these lights set up, how do we actually come in here and bake? We're going to need to find the rendering menu to do this, and you can find that under the Windows tab, under rendering, and you'll see you have an option here called lighting. Now there's a couple different options in here, but what we care about here is this one called lighting. If you go and open this up, this is going to give us the master rendering menu for this scene. And you can see we actually have a couple different inputs here. We have environment, real-time, baked light maps, and these are all different things we have access to. Now, in this case, the environment you can see actually deals with the sky dome. We're not going to get to that right now, but what we care about here is the scene lighting here and getting this set up. So you can see here, it has different light setting assets. You can create a new one or clone an existing. In this case, I actually do have one for my sandbox, which is kind of interesting. Not really sure the deal there, but we could just click a new one for this particular scene and it will create a new profile down here in my tutorials. And I'll just make this my tutorial light bake asset, so that way we have access to it. And this is going to allow us to adjust the different settings in here for the purpose of bake lighting. Now, we can adjust the progressive light map to either be a progressive CPU or GPU. CPU uses your central processing unit and is generally what you want to do. The progressive GPU, the advantage of this is it says preview there. It can allow you to kind of adjust lights in real time that are baked. So the idea is that your graphics card is going to do the work updating that. We can leave CPU for now. Samples for direct samples, indirect samples, and environment samples. These are all going to essentially equate to quality. And you can read more about this in the Unity documentation. There's filtering, which also deals with different types of quality. Light map resolution, the texel per units, that size, light map size, all the stuff. These are going to affect the quality of your light maps. And just like with any other texture, what this comes down to is a higher quality is going to be a higher data load. So you'll figure out more of that as you go, working in games. Like I mentioned, there's tons of documentation you can read up on it. Off the top of my head, I can't give this to you. On most game projects, it is really figured out on the fly, scene by scene, depending on what's needed. The main thing I want to show you guys here is this generate lighting button. And if we go ahead and click it, what's going to happen here is it's going to take time to generate the lighting. You'll see our timer goes here. And what we'll see now is that our lighting is now baked. It's baked into the scene. What that also means is for our baked lights, if I move an object, we should see the shadows kind of stay put. Now, let me just double check this was set to bake. It wasn't. So let me make sure that's set to bake, and I'll regenerate this so you can see that again. We'll see this bake out here, and you'll actually see the light disappear. So what's up with that? Baked lighting only affects static objects, and notice everything in our scene is not static. This little checkbox here is static. I think we talked about this before in the kit tutorial when we were making a moving platform. Static means the object doesn't move, and the advantage is it can utilize this baked lighting setup here. So if I go ahead and check static on all of my objects here, we're going to see a much different result once we bake this time. So I'm just going to grab everything in the scene and just check it to static, because we don't plan on having anything move. Usually the only thing that's going to move in your scene are characters and interactable objects. So I'm going to change the children here. Now when I generate the lighting, we should see something different occur, where we get those light maps generated and we actually see the lighting appear on surfaces. Now, what's happening when the light maps are generated? Unity actually creates a light map for us. It creates a texture utilizing all the objects in the scene. It unwraps their UVs into light map UVs or reassembles them and turns them into a UV that can be used for light maps. Now, you might notice something really big changed this time around once we set those things to static. So you can see a really cool effect we have is our laser gate actually does something. You can see it's actually emitting light with that emissive, and it's actually releasing a really strong light, which is awesome. So we're actually going to have that in our scene if we do baking. You can also see that we got these speckles, these little dots. That is going to be due to the quality. It's one of those things that we might need to hammer out. The lighting here on the walls as well, this is being caused by these lasers because we have all these individual beams, but that's going to be a pretty cool effect, honestly. That's pretty cool. Now, one disadvantage of static objects, though, is if I move them, you'll see those are literally baked. You can see the shadows are burnt into the ground, so these things aren't going to be able to move. You'll also see as I'm moving around here, some of these things are changing. It didn't finish here. You can see this forced stop here on this button and this auto generate. So it actually was not done calculating these when I decided to demonstrate and move things. So I'm going to just click cancel here and then generate again. So that way it can start fresh without me moving things. Since this is doing an iterative pass, that may also be what's going on here with the lasers. I didn't quite notice it wasn't done yet. I just got excited that we had a cool end result. All right, so it looks like it finished with that. This is kind of the end result here. We're getting some really weird results because we have intersecting areas, but check out our gate. Really cool that this light baked onto here. You can see we didn't have to paint that into the texture, into the emissive, because those are actually baked there. Now, one downside is if I do plan to deactivate these laser bars with effects, that may disappear, so we might have to light this a bit differently. So we'll need to take that into consideration. But I think that's about all I wanted to show you about the basic light map stuff here, just so you can understand it. Just to demonstrate now that the light bake has finished, you can see this is a real-time light, so as this object moves, its shadow is cast in real time, whereas this is a baked light. You can see that shadow is permanently there and is not going to move. All right, so that's the difference between baked and not baked. Is baked, everything's going to go into the actual texture of the light map, and with real time, the light could even move and illuminate the scene. Now, reality though is that this is expensive, and if you're working in mobile games in particular, the mobile games I've worked on, we were allowed one real-time light in the scene, and that was usually this one, the directional light. So just got to be mindful of that you may not have the advantage of being able to utilize these real-time lights in a lot of scenarios, depending on what kind of game you're creating and what kind of performance you need to target. If you're working for a next-gen console or PC that's on the higher end, you won't have as many restrictions. Lights are still very expensive, so you probably can't go crazy with them, but light baking is one of those things that's probably going to be around for a very long time because it really helps us artistically and it really helps increase the performance of the machine when the game's playing. Now, that's the basic stuff on lighting. I want to talk about a couple other things we have that deal with rendering and lighting, one of which is going to be things called light probes. Now, light probes are a way we can get bouncing from one element to another. And right now, you can kind of see we have this bright red here. And the only thing that's really making a change in this scene is the red we have on this door here. To make this even more apparent, let me go ahead and switch this from red to maybe a bright green and regenerate our lighting. And you'll see that the green here isn't really bouncing at all. It's not getting onto our environment. All we are seeing is the red light from our lasers getting onto our red wall and on our floor. So light probes are a way we can simulate something called global illumination, and that's the bouncing of light off of surfaces. If you have a really saturated object, like a red ball, you can hold it up to a wall or you can place it on a table, and what you should see is that some light from that ball bounces into the shadow area or onto the ground around it. And the reason why that occurs is because light bounces, right? The way light works is it hits a surface, and it doesn't just hit a surface and get absorbed. A portion of it also bounces off into the surrounding environment. So light probes are a way we can simulate that, and we can create this effect of global illumination in our scene. So I'm going to let this light bake finish here, and then once it's finished, we'll go ahead and set up some light probes for the scene so you can see how to do that and how they work. For the sake of speeding up this demonstration, I went ahead and dropped the max lighting size here from 1024 to 256. That way I can generate the lights a bit faster during this demo. All right, so it looks like this light bake is just about done, and you can see the effect that it's having on the scene here now that we're letting this finish. Once again, I did lower the light map quality, so you can see the light map quality's down, but you can see we're not getting that interaction that I was talking about between green and the surrounding environment. The reds we're getting in the scene are due to those lasers. Now, we might also want to lower the laser intensity, so we can kind of do a twofold demo here on our next bake. We're going to set up those light probes, but I'm also going to come in here to my assets, and under the my asset section where we built this out, in the material here, you'll remember that we set this intensity to be higher. I'm going to set this back down to 1 now that we can actually see the effect it's having on the scene, and we should see a less intense effect here on these guys blowing out. Okay, so let's talk about how to create a light probe. The way you do that is you come into your game objects here and you create an empty game object. This allows us to attach a light probe component to it to affect our scene. We can then name this light probe, and we can add a component here called a light probe. So if we just search for light probe, this will be inside of here. So you'll see we have the light probe group. We can go and attach that, and that will go ahead and place this on here. So it'll look like a bit of a little cluster. We can move this up into our scene, and usually you want to have this around the center of the scene, especially the focal area. And the way it works is these little balls are going to sample the scene when we hit render. Now, we can adjust these by coming into our light probe here, and you can see this option to edit light probe positions. We can click this, and once you do that, you can actually drag these balls and you can bring them into the scene. These will act as little rendering probes, and they will sample the area that they are in. So usually what I like to do is kind of create a systematic sheet here. I don't have a perfect system for these, and there's probably someone out there who has a better system than me. But I have done light probe lighting for scenes before in a professional capacity. So yeah. I have some experience with these little guys. It's not my main focus, though. But the way I like to do it is basically I like to get all the corners covered in the scene. That way we have sampling from all angles. And then add some central volume ones if possible to sample those. Where you really want to look is where high levels of interaction are going to be, and we probably don't need to stack them like this. For example, if I place one here kind of near the floor, I could very likely move this one back here and have this near the corner area. But you want to place them near where things are going to interact. You don't really want it floating in the middle of nowhere because there's not really a reason to probe that area. So in this instance, I would place them into these top corners, into maybe the far corners, and I might add a couple, around the base of these, whatever works. And this will act as kind of our sampling network here that's going to sample this global illumination and figure out where things need to be in terms of their placement. So let's get this last one placed here, and then maybe we can add a few more. It's not rocket science on how to use this. It's a little bit more rocket science on what it is, but if you can come in here, you can see this option to add probe. If you just click that, it will give you a new probe into your system, and then we can go ahead and place this, for example, here to sample the area near this object to kind of calculate the interaction that'll be occurring between this light wall and everything else. I can add another probe here just to kind of sample this area. And then maybe I'll add a probe around the door here. That way we can sample the effect it's having on the surrounding area, but I feel like we're not really going to get too much here. But if I add a probe in front and I add a probe behind, this might help us illuminate the gate a little bit better, which could be helpful. From the front, it is feeling a little bit dark since it's in the shadow. But something like that's going to give us our probe network, and we can exit the light probe editing, and that will just leave them in our scene. Notice we only see it when we select it. I am going to set up a snipping tool here, so I can grab a screenshot of us for the before and after to kind of show you the effect these light probes have. And this is actually something I do in my workflow. I take screenshots, I kind of have them hovering off to the side. Sometimes I will copy them into an image reference board. That way I can see the before and after, because the next step to this is to generate the lighting, to click this. Now remember, we have two things happening. We've added our light probes, but we also toned down the intensity here of these lights. So I'm going to click generate lighting. I'm going to let this run for a bit, and then we'll come back and take a look at the end result here. So let's click that and see the result we get. All right, so it looks like our render finished, and you can see we do have a bit different result. You can see the intensity of these guys here is a bit different. It's kind of interesting we're getting that line around the base. That's one of those artifacts that we can see. But you'll notice we didn't quite get that global illumination I was talking about. The only thing we really succeeded in was changing this material to not be as intense. Now, why is that? If we come into the render settings here, you can see that we have an option here to enable global illumination through the real-time global illumination. And likewise, if we come into the light probes here, sometimes it's good to check if these have any settings, but in this case they don't. Now, in this instance, we'd want to check that real-time global illumination and any associated qualities here. So in this case, just turning that on should work. And we should start to get that through these light probes now. I may have to reposition them for better intensity, but in theory, that should give us what we're looking for. So there's always a complication, right? When it comes to these things, you have to flip some sort of switch, some sort of dial to get those to show up. And let's just double check this time around that there's nothing else we're missing in terms of the base stuff here. We have the light probe visualization. We can expand that. Only probes used by selection. Okay, so we should be good here now that we've enabled that real-time global. And if we go ahead and generate the lighting here, once again, this time around, we should hopefully have that factored in and be able to see the effect it has on the scene. All right, so this time around, we are finally getting some results I can show you with our light bake now that we clicked that real-time global illumination. If you take a look at our white cylinders here, notice the green on these. We don't have a single green light in our scene. So what we can confirm is that we're successfully getting that bounce light to occur. Now, it's not as strong between the ground and the wall as I'd like to see, but it's probably more diffuse and spread out. But we can really see it here between this object here and this object here on the wall, just how intense that green is. So that is what we're getting there with the global illumination. We also might be able to see it in here, but it's hard to say because we actually have that emissive. However, we can also see that this emissive might not quite be as strong as we would like. So I could come in here and dial this up once again to maybe something like 2. That way we can test the intensity and we can dial that in. The process of setting up lighting for scenes is pretty much just that. Setting up things like light probes, setting up your settings, and then clicking that generate button, hoping it looks good, and then making some slight adjustments. Now, there is another light setting I want to show you guys in here that we haven't checked on, and that's ambient occlusion. It's down here, and you can see it's right here where we can turn that on. You might be wondering why ambient occlusion and real-time lighting aren't on by default. 2 reasons. Processing time. It is more expensive to have these turned on. And as you can see with things like light probes, you're going to need to have the light probes in the scene for the real-time global illumination to take full effect of those. The other reason is style. You might not necessarily want those in the style of your game. So when it comes to the lightings, you really need to go through the settings to check how those go. And I think ambient occlusion is probably the last one we're going to get in here. You can see there's different controls for it, but just like before, you can click that generate lighting, and it's going to go through the process of generating this and creating lighting for the scene. So I'll go ahead and let this run, and we'll come back and take a look at the end result, and that will kind of conclude the lighting portion. What we're going to take a look at after this is we're going to talk a bit about reflectivity and reflection probes, so we can kind of finish all of our conversation about rendering in this particular section, and then move forward to finishing our asset for the actual game in terms of setting up Lightmap UVs and getting them applied. All right, so now that we have this all finished, the ambient occlusion is now in here. I probably need to adjust the settings. We can see it a little bit here, and in the corner here, you can see the shading we're getting. Not really spectacular, but this also isn't the most spectacular looking scene. Now, we could definitely increase the quality by improving the quality of the map. I have a pretty low resolution map, and when it comes to things like this red ring, we'd have to troubleshoot what we could do to solve this. So sometimes the answer is just not apparent immediately and requires some work, but you can see the result we got here. And if we go ahead and take a look at this now compared to the first result that I snipped off here, you can see we're getting some more interesting interactions here in terms of lighting. Some things I do want to call out is on this first one, you can see how we weren't getting the global illumination on these little cylinders. You can see here we're getting that nice little green spot, which is really cool. Other things, we've improved the quality of this light here. We could potentially bump this up even more or add a baked light to kind of assist in the lighting of this area. But you can see that's no longer attacking our scene as intensely. So that's nice. But you can see the overall results looking halfway decent. So that's the process of light baking and some of the tools we have in Unity to kind of achieve the look we want. So let's take a look real quick at reflections and reflective materials because they fall into this baking process here. So let me go ahead and move my lighting off screen here and reset my hierarchy since I accidentally put it in a weird spot. And let's go ahead and set up a scenario here for us to kind of just check out reflections inside of our scene. I'm going to create a 3D object here. I'll go ahead and use a sphere since they're pretty basic and easy to see. We'll go ahead and place it in here kind of as a floating sphere. And you can see as I'm moving this, the light probes are kind of attacking it. It's showing us how the light probes are going to affect that. And it's actually applying the light probes, which is kind of neat. I don't believe I had generate lighting turned on, but you can see those light probes are actually generating the lighting immediately. You can see how we're getting that lighting from the gate here, and we're getting all that in real time, which is really cool. So as that actually moves through the scene, it's getting affected. That makes me wonder if they changed it in Unity so that these light probes actually work with non-static objects. I am going to check this to static, however, since we're just going to have it be in here. And let's create a new material for this. Under the tutorial material section here, I'll just create a new material. We'll go ahead and create our reflection or our metal, whatever you want to call it. I'll place it onto the surface, and inside of here, I'm going to crank the metalness up. And for the albedo, I'll just lower this down so it's a little bit darker. And for the smoothness, I'll go ahead and make this a mirror-like reflection. Now, it should be obvious the issue with the reflective material here. It's not reflecting the environment. It looks shiny, it looks metallic, but it doesn't look in context. The same thing's actually occurring to this, to our object here. We just don't recognize it because it's not a mirror-like reflection, but pretty much any of these metals should have some level of reflectivity. To achieve that, we need to introduce a reflection probe. To do so, just like we did with light probe, we'll create a new game object, create empty here. We can call this reflection probe, and I'm going to set this to 0, 0, 0. And as you might have guessed, just like we did with the light probe, we're going to add component here and just type in reflect. And in here, you'll find this option here called a reflection probe, and we can add that to this. Now, the reflection probe calculates reflections from the point of the scene that the reflections occur. This bounding volume represents the volume in which reflections are going to be calculated at. Depending on your scene setup, your output target, mobile versus console versus PC, you could have more reflection probes in a scene or less. Generally, I use one where possible. That way we cut back on processing power. But there's also different types of reflections. You can see baked, custom, and real time. So just like before, if we set this to real time, you can see the effect that's going to have on the scene here. And now the sphere is actually going to reflect in real time. Just like with lighting, these are more expensive because they're going to affect actual active objects and they're going to be rendered constantly. So it's very rare that you get to use real-time reflections here, but for the sake of setting up things, it can be quite nice. You'll also notice the reflection probe acts as a reflection as well, but when we actually look in the game view, you'll notice the reflection probe isn't there. I'll need to move the sphere of the game camera so you can see that. What we're seeing is our actual sphere. The reflection probe just gives us a preview. Now, to demonstrate how the reflection probe works, I can move it around and put it in different parts of the scene, and you can see how it's kind of reflecting from that point and perspective in the scene, and only things contained within the volume here are actually being triggered by the reflection. So as I move that, you'll see they gain or lose their reflectivity. If we take a look at our metal now, you can see just how different that changed. You can see all the reflections of the green walls. You can see red reflections for the actual emissive. And if I go and set this to baked, you'll see all of that goes away. So you can see how big of an impact this is actually having on our object and on our other object here. So once again, real time, we're going to see those in real time. This is great for setting up a scene, making things look nice, or even just checking your asset, because we haven't actually checked the reflectivity on this thing, right? But what we're going to ultimately do is switch this over to baked. And just like we did before, it's going to be baked through this menu using the generate lighting, and it will go ahead and generate the reflections through that data. So I'm going to let this render once again so we can see what these look like once they're done. But once this is complete, this is going to kind of conclude our overview of the basic rendering stuff we have here inside of Unity. So at this point, we've taken a look at the concept of real-time lights, baked lights versus non-baked lights, how they interact with things like static versus active objects, as well as the baking process. And in addition to this, we've taken a look at some additional baking tools in terms of dealing with things like light probes for real-time global illumination, and getting reflections into our scene with reflection probes, seeing how we can do real-time versus baked, and most importantly, getting those reflections to have context of our scene to be contained within this volume. All right, so our bake finished, and you can see now our reflections are baked in here. They are still interactive, which is nice. You can see as I move the camera, the reflections will be there moving with the camera, which is really nice, really convenient. Okay, now one thing I forgot to mention is how to adjust the reflection probe size. So just to kind of wrap things out here, this box on the outside here is the reflection probe size. And if we come in here, I'll switch this to real time just to give us context. You can click this icon here to adjust the size. So these little dots. This will allow you to come in here and adjust this to be bigger or smaller. And generally speaking, you want to try and get it wrapped to the size of your scene without wasted space if possible. Just so it doesn't take as long to calculate, and you can see the effect it has. Not really a big impact here, but if we were to adjust it, for example, here, if I were to move this in, you'd see as that reflection is being crossed over, we are no longer seeing it affected by this reflection probe because it's not contained within it. The other thing I wanted to mention is about the reflection probe being from the perspective of the reflection. I showed that somewhat unsuccessfully. Notice the sphere is inside the sphere zone reflection. If I had moved the reflection probe to be on the sphere, we could, in theory, eliminate that, but we'll probably have to toggle real time here to get that to occur. So now you can see the reflections are occurring from this sphere's location. Okay, so you can look for that in games you play. You might be able to catch weird little errors like that, but you can see now that that sphere will be removed, and if I go ahead and disable the gizmo visibility, we won't see the sphere reflected. We'll see the reflections from that sphere's perspective. But if I move my reflection probe here to something like the gate here, and I toggle the real-time on and off again to kind of capture the new scene, you'll see that it is going to be actually reflecting itself. Most players probably won't catch that, but you do have to be mindful of how you place those. Okay? So that's going to conclude the rendering stuff we have inside of here. You can try incorporating this into your scene, but before we move forward, let's touch base real quick on how we could set up a UV channel for our gate here that is custom, because right now what's happening is Unity's just generating its own. I do want to say before we do that, in my experience, Unity does an okay job. There's been projects where they've had me set up a UV channel, so for the sake of just demonstrating how to do it, let's go through the process. But just be aware that if you don't want to do this, you should be fine using Unity's bake for a majority of the assets that you create and utilize. So now that we've taken a look at the bake here, let's hop over into Maya and let's talk about light maps and setting them up. So when we are creating light map UVs, what we need to do is we need to create a second UV channel. So for some of you who are newer to 3D, this might surprise you, but you can actually have multiple UV channels on a single object, and you can even map multiple inputs to those channels for more advanced workflows. This is done in both games and film, so it is a great technique to be aware of. We're not going to be doing anything super fancy in here, but in this instance, we will be creating a second UV channel for these light maps. Now, there's some things that we need to be considerate of in terms of what we're trying to achieve. Every surface that receives lighting needs to have its own unique space with a 0 to 1 range. What that means is no overlapping UVs. So in terms of our object as it stands now, we actually have a ton of overlapping UVs. And if I go ahead and turn on the overlapping UV section here, you can see everything is a very dark blue. And that's because we've mirrored this object over, so the second pillar is completely mirrored and on top of it. Not just that, every last single one of our little laser beams is a duplicate of the other. Not that those are actually going to receive light map information necessarily. We could, in theory, potentially leave them out since they're emissive, but we'll include them here for the sake of things, and you never know. It might have a positive impact overall. But we need to make it so all of these are separated. That's going to be one of the purposes this light map serves, is allowing us to achieve that. With that said, multiple meshes can be combined into a single light map to reduce draw calls. So we could even put an entire level into a single light map if we wanted to. And Unity actually does that for us. It doesn't do it object by object. It takes the squares that we generate and the UVs we generate, and it composites together with all the other light maps within a scene. Other things to be aware of is that automatic light wrapping can be a fast way to achieve this, but sometimes it doesn't give us the best results, so we might have to make some adjustments. So let's go through a couple quick best practices here. We're going to want to start with a copy of the texture UVs, which we already have, and they're set up real nice. I'm not going to have to go through a whole lot of technical stuff, but there are some things we'll need to do, like unwrap some of the lasers since they're actually a different size. We want to unmirror and unoverlap areas that are going to need unique lighting, which in this case is basically the whole thing. And we can scale UVs for areas that require higher lighting detail over others. Usually it's best to keep them equilateral, but in some cases, if you're limited on a light map space, it's good to do that. So how do we do that? We can come up here to this option called UV sets. We can open the UV set editor, and you'll see we have a map 1. All we need to do is click copy, and this will create a second UV set. For most workflows, what we're going to do is double click this to change its name and switch this to Lightmap. From here, whatever we click on is the one we're working in. So I will have Lightmap clicked into here, and I could come in here and do something like a modify layout. Remember, my Unfold 3D hasn't been working, so if I apply that, it might not give me the best results. Ironically, it started working again. So when I was doing the UV layout demo, it wasn't working. Now it is. And we can actually adjust this to fit our needs. But before we do that, we might want to do some unfolding as well. Just to show you, though, the textures have not changed on our object, and that's because if we toggle between these light maps, you'll see light map 1 is untouched. That's what our UVs are applied to. Light map 2 here is actually actively in our scene. Now, like I mentioned, we might want to unfold these, and we might want to adjust scaling. In the case of these, I'm just going to grab all of these by shift double-clicking them in face mode. You could also do UV shell mode, but I'm doing face mode for whatever reason. And we could do a modify unfold on these to make it so they unfold correctly. And that should be fine. We might also want to do a modify straighten UVs. That way they're just straightened out and they have nice edges. From here, we can select our object again, together with the lasers, and we could do another layout here with our layout and hit apply and see if it works. So in this case, I might have to select these again. Let's just apply with our, that's our unfold. Is that? No, that's layout. Okay, so yeah. Now, this is not optimized for light maps. In terms of light maps, we want to use the space as much as possible, but what's very interesting about light maps is they tend to be very small. So rather than setting this to a 1024 texture, what's common to do is go to a very low texture size, like 128, and actually give a ridiculous amount of padding, like 16. So what you actually end up with is these really small shells. But remember, Unity is actually going to repack those later. What this guarantees is that we have good bleeds and we don't get weird effects. Now, what are the weird effects I'm talking about? This. This is very likely due to Unity's automatic packing. So I mentioned that we'd have to figure out ways to troubleshoot this. And a way to troubleshoot this is to create our own Lightmap UVs, because this issue is very likely being caused by Unity. So the way we prevent that is by using this large spacing with a small texture size and hitting apply. Now, this might be a little bit too aggressive. I might bump this to like 256 with that spacing, but something like this is honestly what we're looking for Lightmap UVs. We could maybe make it a little bit less spread out, but usually it's better to err on the side of caution. So what we have here now with these Lightmap UVs is we have a nice spread area. We have these, utilizing the UV space properly. We don't have any of these overlapping. We've checked all our boxes. Okay, so that would be the process of creating Lightmap UVs. As far as that goes, this is a UV edit, so we do want to delete history on these. That way we don't carry this over into our save file, but that's going to give us Lightmap UVs for when we export this later. Okay, so just remember that base checklist in terms of Lightmap UVs. You want to start with a copy of your texture. You want to make sure that everything is unmirrored, unoverlapped, that need unique lighting, which is generally the whole thing. And you want to make sure that they have a nice amount of padding, so that way when the Lightmap is created, there's not bleed and you're not getting an end result like this. We'll take a look at this once we export it again after we generate our LODs, but we're going to wrap this up for this demonstration on how to create the maps. After you do create that second UV channel, just make sure you save so that way it's there. And that's going to wrap up this video on light maps and baking in Unity. You've now learned how light maps improve game performance while adding realistic lighting effects, and you know how to create a secondary UV channel to optimize light map quality now that we've looked at it in Unity. In the next section, we're going to take a look at how we can optimize this further by creating things called LODs and create our final game asset that we're going to ultimately bring in the game. If you've enjoyed the series, don't forget to like, comment, and subscribe to stay updated for the latest content. Thanks for watching, and I'll see you in the next one.